So in this video, we saw Michael talking about, or signing, about what happened to his mother and how he became an orphan gorilla. Now, we can't be sure if that's what we're seeing, but if so, that's displacement. The ability to talk about the past and to speculate about the future. This was thought to be only a human ability. If Michael is showing that, is doing that, he's showing that in fact he can remember and talk about or express his feelings about the past. Also, while gorillas would never use sign language in the wild, the fact that they can understand symbols and communicate demonstrates the primate connection, the need for sociality, the desire to connect. Also, the ability to use symbols. Now, there's been studies that show that bonobos use trail markers when they're moving along, piling rocks up. This is certainly a different impression of non-human primates than we've had before. Then we come to the painting. Anybody can put paint on a page, but it's another thing to name that painting. And when you see Stink Gorilla Moore, you really do see a bouquet of flowers, or Apple Chase, and the only colors that Michael used was black and white, and then named it Apple Chase. It is Michael that named Stink Gorilla Moore. So signing the name and being us to be able to see that connection with what that symbolizes is very important. It shows that our abilities have been evolving on this planet for quite some time. And we are a part of all life on this planet. Long gestation periods and slow postnatal growth. For maturation periods, as the nervous system becomes essential in interacting in the world, in taking in information about the society, about social mores, about how to use certain tools. The nervous system takes longer to develop to take in this information. With humans, our nervous system develops almost entirely out of the womb because it is taking in information from our environment and storing it in the neurons for later use, later references, later ways to understand in context what we're experiencing in the moment from what we've experienced in the past. This again begins with primates, that longer maturation rate for the nervous system to gather the information it needs outside the womb. This explains why the helplessness of individuals can be selected for in natural selection, because the benefit of being able to understand your environment and interact in it with opposable thumb hands that can intricately move and manipulate things around, as well as the consciousness of what these things are to greater and lesser degrees. Success of behavioral adaptation. This is measures in terms of energy costs and benefits. How much energy is used and what is the benefit to the individual. Qualitative behaviors measured in quantitative forms. If you remember, a theory is made by quantification and then filled in with understanding with qualities. Strategies. A set of behavioral patterns that have become prominent in a population due to natural selection. And again, these behavioral strategies are increasingly learned from the group, not genetically driven. Kin selection. Behaviours favoring one's closest genetic relatives may be an explanation for altruistic behaviors that appear to be contrary to fitness. In fact, what we see is altruistic acts are not uncommon. We watch the video in class at the end when the bonobos were fending off the people trying to protect that dead bonobo. That's an altruistic act. They're putting their fitness in danger to protect a fellow member. It's uncommon because of the nervous system and the sociality and the connections that primates form. Altruism, acting in a way that has a net loss in energy to the actor and a net benefit of energy to the receiver. An altruistic act. I may endanger my fitness or I may endanger my fitness by sharing food. But what I've also done is I've gained a partner. Reciprocal altruism that is thought to be reciprocated later on. Some kind of act that in a social setting one is assured that will be returned later on. Archonta. This is a superorder designated for the sister order of tree shrews, flying lemurs, placideiforms, and primates. Placideiforms are the early primates that have gone extinct. Earliest possible primates. Found in the Pliocene between 65 and 53 million years ago. This is the infraorder Placideiforms, members of the larger superorder Archonta. The Placideiforms are all extinct today. Exhibited morphological characteristics similar to current primates, are thought to be attributed to other mammal orders as well. The extinction began about 53 million years ago in the Eocene. Divergence of primates. Why do primates have opposable thumbs, nails on the ends of their fingers, stereoscopic vision? Well, these are three hypotheses that don't discount each other, but work to understand the context of how this came about in natural selection. The arboreal hypothesis. Arboreal living was the most important factor in the evolution of primates. Prehensile hand to be able to grasp, the opposable thumb, the adaptation to climbing in trees that would have sharpened the stereoscopic binocular vision, and a variety of foods led to omnivorous diet and general dentition. Of course, this could have been in place already with the mammalian descendant of primates. Visual adaptation hypothesis. Primates may have first adapted to shrubby forest undergrowth and the lowest tiers of the forest canopy. Forward-facing eyes enable primates to judge distance when grabbing for insects. Flowering plants may have influenced primate evolution, hence the color vision. Angiosperm radiation hypothesis suggests the basic primate traits were developed in conjunction with the rise of the angiosperms, flowering plants, that began 140 million years ago. So while primates came much later, because flowering plants were an indication of food, especially for smaller, you have smaller primates, you have pollen and nectar. Angiosperm radiation hypothesis suggests the basic primate traits were developed in conjunction with the rise of angiosperms. Flowering plants provide numerous resources for primates, including nectar, seeds, and fruit. True primates appear in the Eocene epoch between 53 million and 35 million years ago. Diversification of primates. The early primates, the adipoids, can be related to streptorini. The amomoids can be related to haplorini. These are the very earliest primates that then became these other forms, and possibly even the semiform anthropoids, those that become human-like in their appearance. Amomoids, up the top, and adipoids at the bottom. Again, some of the earliest primate fossils found. Egyptopithecus. A skull of Egyptopithecus. This genus has been proposed as the ancestor of both Old World monkeys and hominoids, primate traits with 2-1-2-3 dental formula. So those would be Old World primates, Asia, Africa. Egyptopithecus was found south of Cairo. Proconsul. Skull of proconsul is the best known of early Miocene dental apes. This would be considered an ape. The dental formula 2-1-2-3 is being used. The Miocene is from 23 million years ago to 5 million years ago. Anthropoids. These include monkeys, apes, and humans. The anthropoid part, the anthro, means they have what we would consider a human shape. Anthropoids. Anthropoids. Hypothesis for how anthropoids got to South America. Convergent evolution. That mammals on both sides of the planet evolved and converged on similar ways to exploit niches through becoming primates. Evolved independently of one another. The evolution is due to adapting to similar environments. And then there's an idea, hypothesis, migration from North America to South America. Migration from Africa to South America. And remember, only New World primates have a prehensile tail, a tail that can grab, and or the dental formula 2-1-3-3. As we look at this, we can look at 200 million years ago, 135 million years ago, 35 million years ago. We can see 135 million years ago to 35 million years ago. The North American continent and the Asian continent were still connected. So primates could have crossed over the continents and moved around. Also, somewhere between 135 million years ago and 35 million years ago is when Africa and South America split apart. If primates were around prior to that split, and they could have crossed over because it would have been one landmass. Hominoids. They have the same skeletal structure as you and I. The bones themselves are different because they've adapted to a different niche, different locomotion. Hominoid primates, contemporary and extinct apes and hominids, radiate during the Miocene epoch. Africa is the place of origin. Eurasian forms appear after the mid-Miocene, so approximately 10 million years ago, 15 to 10 million years ago. Decrease in diversity by the end of the Miocene. The end of the Miocene marks Africa becoming much more arid. 10 million years ago, Africa was coast to coast covered with forests. As the climate began to dry out, forests began to get thinner and savannas grew between the forests, changing the niches that could be exploited. Evolutionary relationships among fossil primates. On the right here we have an extinct primate living in the Miocene about 13 million years ago in Spain. This is an ape. Researchers debate specific relationships. Best representations of primate evolution reveal patterns and trends over time.